If you would please join me in welcoming Jacob Putt from UCF, Tim Allison from SWRI, David Alonzo from Mitsubishi Power, Laura Parkin from Air Liquide, and Katie Perry from Siemens Energy. Oh, there you are, Dr. Putt. The panel is yours.
The first panel of the day. I'm Jacob Putt, professor in the Department of Mechanical and Aerospace Engineering, and also the director for Machinery and Energy Research. I'll be moderating this panel, and I'll be assisted by my colleague, Professor Suvidvas, who is at the back of the room, for looking at the online audience. Well, as the title says, the time for hydrogen is now. As we heard, it is very important for the long duration energy storage and as well as for sector coupling. Requiring engineering and scientific innovations and collaborations that we have heard for the last hour or more than that. This creates exciting opportunities for today's students who will be tomorrow's industry leaders and experts. So we'll now hear from 5 top experts, thought leaders, and decision makers in the field about developing and deploying hydrogen infrastructure. With this, I'll now request each of the panelists to give a more elaborate introduction of what they do, and also to address 2 topics. Why is hydrogen important, or the hydrogen and technology and decarbonization important for yourself and your company or organization, and how can academia play a role in that process? I'll be starting with Tim.
Okay, I think I'm on. All right, so good morning, everyone. I'm really happy to be here, so thank you, Jay, for the invitation. I'm Tim Allison from Southwest Research Institute. I'm the director for our machinery department there. So briefly, Southwest Research Institute is a private, not-for-profit 501c3 research institute. We're based in San Antonio, Texas, and we're pretty large. We have almost 3,000 employees on 1,500 acres, about 300 different labs. And so we work in a variety of different areas, ranging from deep sea engineering projects and submersibles, all the way up to satellites and clean rooms and running missions for NASA. The part of the organization that I'm in charge of deals with machinery-based power systems. So we work in propulsion, we work in oil and gas, and especially relevant to this group here, we work in power generation. And that includes advanced power cycles. We run test rigs for machinery that operate in power systems, everything from bearings and seals to full-scale megawatt, 10 megawatt scale machinery tests. With hydrogen, we work in doing compression loops and combustion loops, as well as full-scale system analysis. Hydrogen is important to my organization for a couple of reasons. One is, although hydrogen has a lot of potential, to realize that potential, there are still many research challenges that have to be done. So we're trying to position ourselves to have those lab capabilities to support our many clients. And that includes labs on hydrogen production, looking at electrode design, different production cycles. We have, again, some of the machinery-based research facilities that we're doing. We're investing in infrastructure to support large, cost-effective hydrogen supplies for our different labs. So we want to be best prepared to handle the research needs. The other reason hydrogen is important to us is that actually I'm leading an effort to determine what options we have for creating a net zero pilot at Southwest Research Institute. That's a 10 to 20 megawatt scale microgrid, and hydrogen plays into an option where we would use renewables to create hydrogen and then produce net zero power that way. In terms of academia, we actually, we do research, academia does research, but I don't see that as a conflict. In fact, it's a really successful collaboration pipeline. Our focus tends to be very applied, more applied than what most of academia does. And so we actually have partnerships with many different universities on our research projects, including some successful partnerships with UCF, Dr. Kapat, Dr. Vasu, looking at combustion and heat transfer, and even hydrogen storage and ammonia type systems.
All right, thank you. So good morning, David Alonzo with Mitsubishi Power. I have the pleasure of following after our president and CEO, Bill Newsom. So Bill did a great job touching on the role that hydrogen is playing within our organization, a lot of the projects, even to go as far as our mission statement and how hydrogen plays a role in that. So I'll focus on the second part of this question, the role that academia can play. I will admit that when Alex mentioned differential equations, I had a really bad flashback because that's the one course that I failed in college. But the reason I mentioned that is it set me on a different path than the path that I'm on now, which is more on the commercial side of the business. So lots of good discussion about technology and research, and even this morning the discussion from the DOE on funding technology programs. I'd like to say that also academia can play a role in all the other parts of the business to further this into a true hydrogen economy. So, business acumen, things like, finance and financial controls, project management, all of those are part of what we do. We also spend a lot of time in our organization on modeling. So looking at the markets, working backwards from those net zero goals of 2050. So working with our customers, some of who are here today, in collaborating again and trying to determine, what does that future power generation system and grid look like, and what can we do to help them, bring the technologies, the solutions, but also even so far as, some of the project development. So wanted to make sure that I mentioned all of that. I know, lots of engineers in the room here, but, we also need that business side and that acumen to make this successful.
Thank you, David.
Good morning, and thanks for having us this morning. Really appreciate it. So my name is Alex Hoffs. I'm the president of Power Systems Manufacturing, or short PSM, recently acquired by a large company called Hanwha, based out of South Korea. Now, I didn't have to travel that far. I live about 2 hours south of here in Palm Beach County, and that's where we have about 400 engineers and support staff to work on service for gas turbines. So our core expertise is retrofitting existing equipment to modernize that equipment. So we've been in decarbonization, I would say, for the last 2 decades in reestablishing these machines to run environmentally friendly in the US and overseas. So decarbonization is important to us, of course. It's a core what we do. Innovation goes along with that. So we love innovation. I'm an engineer by trade. We have probably 40 to 50% engineers or engineered background in our company. And we listen to our customers and industry and stakeholders, and we try to understand how we can bring that into our product portfolio. And of course, decarbonization and hydrogen are becoming very, very important topics for us as an industry and as a company. So where do we then do research? Bill Newsom has mentioned the levels of hydrogen that I'd say larger gas turbines, we're talking about FH and J class, are today capable of, I'd say 20, 30, up to 50% you mentioned. Those are still fairly moderate levels of volumetric flow. So volumetric flow, if you translate this into mass flow at these levels, it's about a factor of 3, of 3. I think you said 20% is about 7% in mass flow, and that ratio improves as you increase the volumetric flow. So there's a lot of research still required and development required to increase the ratio of hydrogen and natural gas to burn in a gas turbine in a safe and reliable manner. And we talk about a lot of CO2 today. There are also other emissions, is NOx, for example. So today's modern gas turbines run at single-digit NOx. Okay, so typically 9 ppm and below. Then you have a scrubber, you can go down to maybe 2 to 3 ppm. But that's also something we need to pay attention to as we continue to increase the volumetric flow of hydrogen in these large engines. And that's where we need help. That's where we need further development. That's where we need testing. That's where we need smart people to really figure out how these advanced type of combustors look. We need people who can also are not afraid of going out to site and implement these solutions. So as much as I still remember also differential equations, it's not all about that. It's also about demonstration project, as Dr. Wilcox said. We need to put metal on the ground and we need to learn. And that's where we need help also from academia and talented people to be able to go out there and do exactly that.
Hi, my name is Laura Parkin. I'm Vice President of our Hydrogen Energy Group for the Americas with Air Liquide. And Air Liquide's interest in decarbonizing is not only the fact that we have existing operations that we need to decarbonize, but also we want to help our customers decarbonize. So we have goals in terms of the hydrogen that we've been producing for industry for 60 years. Now we're in a position to want to decarbonize our operations, both in our industrial gases and in our hydrogen space. And we have goals set for, as many of us do, 2050 for neutrality. But to reach the trajectory required to get to 2050, we have a goal in place for 2035 to be 1/3 down on our decarbonization. A big piece of that is decarbonizing our hydrogen production. I'll also say that on the academia side, excited to give an example of something that we are working on here at UCF, and there are team members I see in the crowd today I was talking with earlier. And I'll mention anecdotally, my father worked for NASA his whole life, and it happens to be a venture with UCF, Air Liquide, SWIRI, if I'm saying it right, and NASA to develop the next generation of a novel hydrogen storage technology. And it's exciting to be, I think, on the forefront of that, working as the themes are in this day, collaborating with a variety of people who represent talent at different levels in their career, and to develop the latest and greatest technology, because it's going to take all of us a lot of diversity to get there. And I'm excited to be here today.
Thank you, Katie.
Yeah, thanks for having me. Katie Perry here. I'm a business development manager for the Americas at Siemens Energy, so literally across the street from UCF. And I am personally excited about hydrogen because I work specifically with our own hydrogen electrolyzer, our PEM electrolyzer, that is our own design for the last 10 years. And I know that I am making a difference today for the future. And so that's what makes me get up in the morning. And of course, working with academia, Siemens Energy, that was mentioned during the previous speakers, we have decades of collaboration with UCF on the R&D front, hosting turbine classes, and it will take those that are younger generation to come up, get involved, have those ideas so that we can collaborate and then implement them on the corporation side.
Thank you. Well, there is a lot of great discussion in the media from many organizations, including companies like yours, on the role of hydrogen to simultaneously reduce carbon in the power and energy sector while maintaining reliability in the electric grid. Can you talk about some of the challenges in accomplishing both simultaneously? And I will start with Alex.
Thanks, Jay. So renewables are inherently intermittent, and we've heard now a few times, and Dr. Wilcox has laid it out well. We still need thermal power to balance the grid, and we are seeing this here in the United States and overseas. As the renewable content of the electric grid increases, there's actually more need to balance the grid with thermal power. And so that's where of course the decarbonization of the hydrogen comes in for the thermal industry to really bring us to zero and carbon neutrality in the future. So what are the challenges here for us in this regard? I just mentioned earlier there are other emittents. There's also NOx. That's something we need to control as we increase the content of the volumetric flow in these advanced engines. So that's something we need to continue to work on so that we don't trade one good for one bad in reducing the carbon from these engines. I know there are some techies here in the room and perhaps also at home. So let me talk about flashback. This is very specific to gas turbines. Hydrogen is a very quick burning gas as opposed to natural gas. So ideally in a thermal engine, you want your flame to go downstream. And there are many technical challenges to do exactly that. When you introduce a gas with a very high speed, you risk so-called flashbacks. So that means that your gas goes the other way. And that's something you do not want because that burns your hardware. And so those are elements when we talk about reliability in the energy sector and also for our customers that are very, very important so you avoid these nasty things and end up with burned hardware. Now, I don't want to scare anyone. There are a lot of means to prevent that. But when we talk about challenges and also technical challenges, I think we have to mention also some of the risk. And that's also why DOE gives money to collaborate and make sure that these engines can run in a safe and reliable manner.
Thank you. Katie, you'd like to add something?
Yeah, absolutely. So I think there's several things that we can address currently. One is to address our current fleet, seeing how we can optimize and increase the efficiency for our current gas turbine fleet. And as well on the nuclear side, how can we implement hydrogen near nuclear to use their base load in which they are not using that power to then produce hydrogen as a sector coupling from various offtakes and feedstock. And then third, as we continue on this hydrogen front, how do we then introduce new technology, PEM, alkaline, AEM, to then collaborate and really push the hydrogen market forward? And it's not going to take just Siemens Energy, it's going to take Mitsubishi, Plug Power, and all of the other competitors to really lift up this hydrogen market.
Thank you. Would you like to add something to that?
Yeah, let me just echo what Alex and Jennifer said about the role of hydrogen as an energy storage thing. That's really, in our perspective, where hydrogen fits the best. And just for perspective, right now we accomplish most of our energy storage and transport through oil and coal and natural gas. And I looked up some numbers. So the U.S. stores in big underground caverns about 1,400 terawatt hours of energy. That's 2 to 3 months of our hydrogen use. The amount of oil storage we have is comparable, and then there's also storage using coal. Compare that to the capacities of like lithium-ion batteries that are being put on the grid, and they're not even a drop in a very, very large bucket. So there's a really humongous need for long durations of storage. And there are a lot of different technologies that try to handle this, but if you look at the technologies and how long they can discharge at and how long they can be stored at, the ones that really work at the seasonal or months and weeks long scale are mostly derived, they're hydrogen-based or hydrogen carriers using hydrogen to create synthetic fuels like ammonia or methanol or things like that. And so there's a really big niche there that's hard to fill with anything else. So we see hydrogen as an important part there. The other part is transport. So hydrogen is comfortable to transport in the sense that it mimics some of the transport systems that we have, big pipelines with gas compressors. There are some important differences of hydrogen I'll talk about a little bit later, but we do see that that's an advantage of a hydrogen-based system, is that we can do pipeline transport, which is still a whole lot more efficient than electrical transport.
Thank you, Tim. Well, coming to the next question, how does hydrogen work in conjunction with renewables in your thoughts on decarbonization, or doesn't it? Maybe I'll ask with Laura.
Sure. I think hydrogen, when you think historically, as I mentioned, we've been in it for decades, was going to various markets. And going into the future, as has been mentioned, it's not only a great product to be supplied for various reasons, but also as a storage mechanism, right? So you've got the intermittency of renewable energy production through solar. The sun only shines part of the day. You have the intermittency of wind and fluctuation. So that kind of intermittency, you can produce power, you can create then hydrogen from the power, store it in large quantity, and then utilize it when you need to bring stability to meet the demands on the power side. So that is as one way of looking at the renewable aspect of this. The other is, and I didn't mention earlier, but a big part of what Air Liquide is also doing is looking at not only decarbonizing our existing assets and continuing to provide hydrogen to industry, but to make it clean and also to advance it and investing in more hydrogen production, for example, for mobility. And that'll be there'll be a big uptake on, particularly I would say in like the heavy duty trucking space, eventually in maritime and aviation. And so being able to take those mechanism or that transportation mode today and change it and convert it into hydrogen, which is renewable versus the fuels that are being used today, is another way that will advance that.
Yeah, to further the decarbonization today, we must implement renewables, more renewables on the wind and solar side, coupling it with some sort of storage, whether it's Air Liquide's pipelines or what have you. For the electrolyzer that we manufacture, we can use those renewables intermittently with our system. So we're already there, we're already ready to implement. In fact, Air Liquide and Siemens now have a joint venture together on manufacturing. And so it's quite important to couple those both to then create the green hydrogen economy along with the tax incentives from the DOE for utilities and developers alike.
Thank you, Katie. Well, coming to the next question, what is your organization's vision on the production, storage, distribution, and conversion of hydrogen to power and energy? And since Tim, you mentioned something earlier, so maybe I'll ask you first.
Sure. Well, I think, we see a role for hydrogen in all those parts, production, storage, distribution, and conversion. On transport, we recently actually did a study where we looked at the impacts of blending hydrogen from 0 all the way to 100% in a pipeline. And we were looking just at the impacts on the compression infrastructure along that pipeline and what would be required to do it. And there are challenges there. Hydrogen is a very light gas, can still be compressed with a centrifugal compressor that's commonly used in gas pipelines. But it requires a lot more work to compress the same energy content of hydrogen through a pipeline. And so in our study, we showed that work actually goes up to about 5 times the amount of compression work that you would need if you were just moving all that same energy through natural gas. And the way you have to do that is you have to add more stages of compression, or you have to make them spin faster. Those are the 2 ways to add compression work. And right now there's material limits on how fast you can spin with existing designs. And so, by adding compressors, we're talking about adding some just in series, more and more casings, or in parallel, compressors that run next to each other, and that adds cost. And so there are some challenges there to address with advanced compressor designs. And of course, all compressors that run, most compressors that run on gas pipelines, they use very low leakage seals, but they do leak. And as the cost of hydrogen is relatively high compared to natural gas, that leakage becomes more of a concern, as well as for some of the other things that Jennifer addressed. So we do see some challenges in the transport network, but I think that there are probably engineering solutions there. In terms of vision on our on-site power generation, we see a role there for microgrids where you can, if land is available and solar resources available, as in our case in San Antonio, Texas, we see a chance to create hydrogen from solar photovoltaic, store it, and then utilize that with a gas turbine or potentially a fuel cell for power generation.
Well, that is where you come in, your company, Air Liquide.
So I would say, again, not to say it too many times, but leveraging existing, right? Leveraging existing technology, existing infrastructure that's in place, and the current needs as a stepping off point to further advancing additional production and distribution. Knowing that we have certain technologies today and certain systems in place today that we can convert and transform, that we can continue to build and add on to, is going to play an important role. So diversity in terms of types of production. For example, we were talking earlier about the diversity that the DOE is sponsoring in terms of advancing the types of production and distribution. So being able to leverage what we have today, being able to convert what we have today, in addition to, as Katie mentioned, taking things like electrolysis and the funding efforts to try to promote the diversity on that production front, and to leverage then what all of us can contribute in terms of technology. We have a lot of various technologies in Air Liquide as well across that value chain, as well as other companies here. And being able to take all of that and leverage what exists today, what innovation is needed to then bring lower cost so it's more affordable for all, and then taking the opportunity of what's being supported in that public-private partnership with the government to be able to advance those in terms of scale and density in various areas are all going to be components to us being successful across that value chain.
Okay, well, now that we heard a lot of pioneering work from Mitsubishi earlier today, so David, if you add on to that.
Sure. So I won't repeat a lot of what Bill said earlier today about some of the project development, the successes we've had here, working with DOE, working with partners within the industry to help us across that entire value chain. So I'll take a different approach and talk about some of the broader things that we're working on and have been working on for a number of years, even into the last decade. Being part of a global entity like Mitsubishi, we have the benefit not just of working with programs like DOE here in the United States, but also some of the national programs in Japan, where we've done a lot of the hydrogen testing, the blending, some of the initial rig testing we did back to 2018 that allowed us to be successful in those projects here in the U.S. to make the commercial guarantees. So I think we've benefited from that. I think here in the U.S. and in the Americas in general, we'll see a lot of those benefits. And it's not just hydrogen itself, also looking at ammonia. Again, being part of a Japanese company, an island nation, it's important to determine, for energy security purposes, how you can produce in country, but also how can you transport. And ammonia has been, again, proven to be one of the lower cost solutions today to be able to transport. So again, as part of the overall broader MHI family, we also have a group that does compression. Again, it's different. The hydrogen molecule is different than what natural gas looks like. So there are challenges, technical challenges there that team is looking to meet. We have a part of our company that's involved in shipbuilding. So the transports of ammonia and how to do that safely and efficiently. And again, carbon capture was mentioned as well. That's another part of our broader MHI umbrella. So, we talk about partnerships across that value chain, and whether it's with universities, whether it's with customers, as Bill mentioned, or other parts of the chain, whether it's production, transportation, or utilization. Really proud of what we're doing and excited to see it brought to commercial scale here.
Thank you. And you used a keyword, ammonia, that,
Yes.
as President Cartwright mentioned earlier, very close to our heart these days. So with that, I'll go to the next question. What investments is your company making in hydrogen? And in this case, we'll go around the whole panel. So Tim, why don't you get us started?
Sure. And my view might be a little unique as a research institute, but we are actually making some investments in hydrogen. We just installed a liquid cryogenic tank that holds over 17,000 gallons of hydrogen. And that's because the research needs to develop technologies for hydrogen have increased, and we foresee that as a lower cost way for us to provide research grade hydrogen to our labs. We're actually also making upgrades to our combustion test facility. So we have a large scale multi-megawatt combustion test rig that has run to 100% hydrogen in past years, looking at part load and full load, flashback, all those kinds of things. We're upgrading that system to run with ammonia as a fuel, following again our clients' interest in those capabilities. We also do invest through just where we put our effort in project partnerships. So again, we have some project partnerships looking at hydrogen for high turndown situations in gas turbines, 100% hydrogen combustion in gas turbines, ammonia fueling infrastructure for airports, supporting UCF in a project there, and then a project on hydrogen storage in a cryogel, like Laura mentioned. So working in all those areas.
Sure. So I'll expand on something that Bill mentioned earlier as well, that was announced a few months ago. You know, one of the things that we do at Mitsubishi is we always pride ourselves on demonstrating in our own facility, our own power plant that just happens to be co-located with our Mitsubishi Power headquarters in Takasago in Japan. And what we announced earlier this year was Takasago Hydrogen Park. So, you know, not only are we demonstrating our latest and greatest technologies on you know, the power production side, but our intent is to now be able to demonstrate the hydrogen production piece and storage as well. So looking at, you know, different types of technologies, electrolysis, pyrolysis, being able to bring these to scale, make sure that we can integrate them, ultimately use that hydrogen that's created in our own equipment to demonstrate again in one ecosystem. One other thing I'll mention as well, again, I think Bill mentioned we even have a smaller frame gas turbine, a 30 to 40 megawatt gas turbine there. We're also looking at direct combustion of ammonia, which when you talk about NOx, yeah, figured I'd get that face. When you talk about NOx and combusting hydrogen and the challenges there, you have even greater challenges when combusting ammonia. So we're starting on probably our lower firing temperature turbines to learn there as well, but there's a lot of interest again in distributed generation, island nations, places that struggle to get that carbon-free fuel. And again, we see ammonia as having real potential there, and we're excited about that as well. So, and again, in terms of investments, it's across the entire ecosystem. Bill mentioned the large amount of money. That's not all just in-house investment. We also, you know, are looking at different technology providers, you know, kind of in that mid-stage, maybe not in the labs here in the universities, but as they're starting to become commercial. How do we invest, provide, you know, some of the initial equity funding in those technologies so that we can bring them to scale and ultimately deploy them here in the U.S. So,
I'll put one comment. Every time that you say challenge, we see opportunity.
absolutely, yes.
With that, I'll get to Alex.
Thanks, Jay. So, as I mentioned before, we are owned, PSM is owned by a Korean company called Hanwha. And let's talk about the hydrogen infrastructure, because that's really what we need to discuss. So if we start at the production side, where does hydrogen come from? It can come from natural gas, blue hydrogen, where you will sequester. But of course, the ideal state would be green hydrogen coming from wind and solar. So Hanwha is actually one of the largest producer of solar panels here in the United States. And now, of course, with the Inflation Reduction Act, Hanwha is looking at additional investments here. So these solar panels are produced in Georgia, and we're looking at expanding that facility in the near future. If we go further, downstream, sequestration requires compression to put CO2 into salt caverns. So Hanwha owns a division called Hanwha Power Systems, and is currently making additional investments into that company here in the United States to increase its portfolio. Moving further downstream, we recently announced that we have a collaboration with Tallgrass. Tallgrass is a large pipeline company here in the United States, and this MOU that we signed is meant to collaborate with the infrastructure here in the United States. Moving further, Hanwha recently purchased a company called Cimarron. It actually was founded by former NASA engineers, where the know-how from rockets, Cape Canaveral was mentioned before, is taken to produce a very sturdy composite tanks to be able to store and also ship or truck hydrogen across the United States. And last but not least, the company I'm president of here, PSM, was recently acquired by Hanwha for the reason of investing in hydrogen. And we talked about Japan. Let's talk about Korea for one moment. Both island states. So Korea is also very, very interested to become less dependent on fossil fuels. Korea is investing heavily in the hydrogen infrastructure, and one of those investments is actually in a chemical park where we just recently relocated a mid-sized engine, a gas turbine, about 130 megawatt, an older frame that we put into a chemical park where we have refinery gases available right now to demonstrate up to 50% hydrogen. This is planned for beginning of next year. We are currently putting the infrastructure in place. So lots of investments. Again, I'm trying to also show the bigger picture. It's not just about the combustion of hydrogen. It's also about getting the hydrogen to the engine and making sure that the entire infrastructure is understood.
So at Air Liquide, we are investing from production all the way through distribution. And with about $1 billion having been spent already in hydrogen in the US, $5 billion globally, our commitment until 2035 is to add another $10 billion in investment in clean hydrogen. And in doing that, we're looking at where we will invest. I'm happy to say being in the covering the Americas, and with recent government funding efforts, that's hoping to accelerate that for us, for a good portion of share of that to be utilized here. Being able to not only invest in the systems that we have today, but also decarbonizing them means CCS in a lot of places, and we have those technologies we plan to implement. We have also, as we talked about earlier, additional technologies on the production side we're looking to invest in, and as well as liquefaction, which we have a technology for, and we're advancing. We have distribution technology not only through pipeline, but also through vehicles, particularly in the liquid space. And we even have technology on the hydrogen refueling system side, so the HRS. These are all things we're investing in globally today, and we're investing in the US as well. We have a new, I like to call it flagship. It's a beautiful plant in North Las Vegas in Nevada, where we produce liquid hydrogen for the mobility market as well as industry. And very excited to have that facility now running for Air Liquide. It's our largest liquid plant in the world. So some areas of investment with Air Liquide.
Thank you, Katie.
Yeah, at Siemens Energy, we have a sort of a unique opportunity on both sides. The gas turbine side, where we are investing in injecting hydrogen into our gas turbines. Currently, we have one that can produce 100% on hydrogen, others that we're at 30%, and we will be at 100% by 2030 for all of our gas turbines, our large gas turbines. So on that front, on the gas turbine side, we're quite excited on our investments. On the electrolysis side, we've been in the hydrogen electrolysis side for over 10 years now. We started in 2011 with our first generation, and now we're on our third with our Sealizer 300. With our next generation, we're still R&D and working through that now. And then furthermore, when it comes to the DOE, and they do release further funding for advancements in U.S. manufacturing, we are then in a unique opportunity to then utilize our existing manufacturing facilities to assemble, package, and then furthermore manufacture our our stacks or our modules that produce the hydrogen to then vitalize the economy here. So not only are we investing on the gas side, but also the electrolysis side. And we also utilize the government funding in other countries as well, mainly Germany, also in the US, and then using some of that funding for different projects. So when we talk about R&D, our flagship for Siemens Energy on the electrolysis side is in Austria, utilizing our latest generation, operating over 3 years now, and we also are investing in the e-fuels, the sustainable aviation fuels. Another flagship for us is in Chile, called the Haraoni project, utilizing wind turbines to then produce e-fuels for a partner in Porsche. So we are all in at Siemens Energy, and quite excited to see the developments literally in the last few years. It seems like it's really picking up speed.
Thank you, Katie. Well, the next question is something extremely close to my heart. Well, as Katie mentioned before, we have got a turbine OEM right across the street from us. We have got another one across the town from us, right, Mitsubishi Power. We have got another one, PSM Hanwha, across the state from us. And if you count others, little bit further south, we have got the Pratt & Whitney Center in West Palm Beach. I don't think any other state in the country can compete with us in terms of the amount of OEM installations that we have got, right? So with that said, I'll basically, the question that I'll be asking is, what skills do you need in your workforce to support all of your visions that you mentioned? And because you hire our students, and that is where we are here for, if there is only one purpose that we have got. So Alex, you hired one of our latest graduates from my lab, so I'll start with you.
Okay, thank you. So differential equations are important, there's no doubt. But I will say that's your entry ticket. Okay, what we really want, and will help you, okay, is to learn, to apply this to a practical implementation of technology. I think that's really, where the rubber hits the road. What do we like to see? We like to see motivated employees, and we'll do our part to it, okay? It goes both ways. We love innovation. So if you love innovation, come work for us, okay? We want to make sure that in the end of the day that you like what we do, okay? So you got to be convinced that we are a company that reflects your values, okay? And I think I speak probably for all of us here. We need folks who really want to excel, okay? And that means you need to bring a good background, but you also need to bring the interest in further technology, for future generations. That's really what this is about. So that's my pitch here for talent, and we do need talent. I think it's an open secret that a lot of folks are hiring at this point in time to advance the decarbonization industry.
And most of the students from my lab has gone to Siemens Energy, so Katie, you are next.
Yeah, I'm not a UCF grad, but when I got hired, they're like, you didn't graduate from UCF? They're really confused. I think that most of the entry workforce for Siemens Energy comes from UCF, which is wonderful, and we're happy to do so. But, we're looking for motivated individuals, but we're also looking for diverse applicants. It is so important, different backgrounds coming to Siemens Energy, because everyone that has a different background, different diversity brings more to the table. And we want to really be a champion of diversity at Siemens Energy.
Thank you. And as we heard from President Newsom earlier, we have got over 1,000 interns from UCF to Mitsubishi, and many of my students are there too. So David, if you...
Yeah, no, and I was actually going to take that and say that's really where it starts, right? So I went to a different university. I was in a co-op program, worked in the telecommunications industry, learned about utility sector there. So I think, it's a real opportunity for the students to learn what they enjoy, what they don't enjoy, and, making sure that there's a good fit before they're hired in right out of college. So I'm proud of that. I know we also, certainly take co-ops and interns from other universities as well. But I think, having that ability to learn on the job while still going to school, I think really gives that individual really a head start when they come in and do start working full time. So, again, I'll mention, as I did earlier, the skill set, the diversity that we're looking for, making sure that we're doing that, from the beginning, and that it helps further our purpose and our mission, making sure that they meet our values. But, again, it's challenges not just in engineering and technology, but supply chain is a big one today, right? So as we look at different technologies, different materials, that's going to be changing. I mentioned project development skill sets, project management, financing, especially as we try to decode all of these new funding opportunities from DOE, tax credits, things like that. Again, it's a skill set that's going to be required to make sure that we understand how that gets translated and further the projects here. So
for a comprehensive university like ours, that is music to the ears, right? Good. With that, since we are running really low on time, I'll be going a little fast in the next two questions. So economic safety, etc., is barrier to hydrogen economy. What do you think, Laura?
Okay, so the task at hand is to be concise. Let me see what I can do. Safety first, so I'll take that one and mention, obviously, there are regulations and designs in place for existing systems, right, in terms of safety, and a lot of that can be referenced and leveraged. Specific to the mobility sector, Air Liquide does work with the DOE and industry and others to help put comprehensive safety requirements in place for the mobility sector, and in particular fuel handling. So there are safety aspects to be designed in for future uses, and that's really important, and it's something that's ongoing and key for our overall success. In terms of economics, one of my talking points on this piece was going to be all about pretty much what had been presented earlier by Dr. Wilcox, as well as been referenced so many times, the obvious acceleration of advancing the hydrogen economy is going to be about public-private partnership in the beginning. We both have to invest, and I'm amazed and excited about the things that have happened just in the last year in terms of the support on that front. So that is obviously going to help advance a lot of elements that will lead to a sustainable and lower cost hydrogen economy. So I'll skip going into all variety of detail. I will also say that on the production and the distribution side, where there are mature technologies, obviously less of an opportunity to have a real step change in lower cost, other than lower feedstock cost. In the space where you're going to decarbonize existing, CCS should come down over time once we implement, and we're providing also at larger scale. Scale is also key going into the future across the board, whether it's in production, distribution, transportation. So scale of the size of facilities being built, or the level of manufacturing in terms of numbers of things being built. So those are some key aspects. I think one of the challenges obviously is getting to an economic scenario that's affordable for all, that we can really transition current fuels to new fuels. For an example, being able to accelerate, build to scale, and utilize the talent, some of whom are in this room, to innovate over time, not only in the coming years, but in the years that follow. Really key to getting the economics in place.
Thank you. Well, jumping to the last question of the panel today, can you define what is meant by curtailment of renewables and say a few words about it, David?
Sure. So again, short and sweet. So I mentioned earlier, a lot of the talent that we've added in our organization over the last few years has been in modeling, right? How do we understand what the system will look like in the following decades? I spent an hour and a half with a customer in person in Michigan, going through the modeling, telling the story of how you're going to transform, what the technologies are to get there. And really it to back up to today, it's recognizing what that challenge is, right? what is meant by curtailed renewable energy and why is long duration storage needed. So spent an hour and a half with the customer. At the end, I'm packing up, and their chief transmission officer looked at me and he says, hey, I have a really simple way of thinking about this. Right now, most utilities plan for their peak load demand, right? So let's say it's in the summer, or in some states now it's in the winter, peak electric demand, and in this case, this customer, their peak demand is about 8 or 9 gigawatts on their peak system day. So they've asked their Public Service Commission for approval to build 8 gigawatts of PV solar in Michigan. Now, we can argue about the effectiveness and the efficiencies of solar in Michigan, but in a very simplistic way, at the very end, he says, you know, that's great in the summertime when the peak demand is there. He says, in April, he says, my peak demand is only 4 gigawatts. So in that future state, when I build out 8 gigawatts of PV solar, in a sunny hour in April, I could be over-generating by 4 gigawatts per sunny hour that I have to curtail or basically just, you know, unplug. And that's, you know, that's what we're trying to capture. That's where hydrogen comes in. We talk about long-duration storage. So I always use that example. I've told them I use that example. I said, hey, I'm making you famous now. But it's a very simple way of thinking about what that challenge is. Right now, most utilities are going gangbusters building PV solar, right? It's cost effective. That's where the demand is, and that's what's going to happen the next 5 to 10 years. California is already seeing it in terms of curtailments. I think earlier this year, they were close to 300,000 megawatt hours in the month of April, I believe it was, of this year. Again, you know, carbon-free energy that we don't have anywhere to put. So battery energy storage meets part of that, but really it's the long duration. How do I shift from April to that peak demand time in the summer? So.
Team, would you like to add some last words on it?
Totally agree with David. The only other thing I'll add is just that, you know, that's part of the challenge. You know, using renewables to create hydrogen introduces the economic challenge because they're so intermittent, and you know, the curtailment events that eventually can feed into energy storage are really relatively rare. You've got all this investment around infrastructure to make hydrogen that will only run a small amount of the time, and so that goes into then increased cost, and that's one of the big challenges that we see with economics of hydrogen.
Well, we come to the question portion of the panel, and I thank each and every one of you. With that, I'd like to open the floor for questions. Since we are running real low on time, probably would not be very many questions. So coming to the floor, anybody from the live audience who likes to ask any question, please state your name and affiliation.
Don't all go at once.
George Grammaticus from TTS Energy Services. The holy grail for OEMs in the gas turbine business was always efficiency. How has that changed?
I guess I'll take a first swing at that. So, again, short answer is that is still the mission, right? And that's always been the mission with Mitsubishi and how we're continuing to advance, like Bill said, our latest JAC gas turbine. So getting it, you know, 64, 65% cycle efficiency in combined cycle. I think the target, the design philosophy that we're aiming towards is, you know, as we mentioned, hydrogen has a lower energy content. There's more volumetric flow. Really, the challenges are in combustion primarily. So whether it's the fuel feed into the combustion system or the combustors themselves, as was so eloquently described earlier. But, you know, still the same targets in terms of, you know, airflow, firing temperatures. There's different challenges in what the exhaust constituents are when you start looking at higher content, higher percentages of hydrogen. But I don't think that mission changes. So hopefully that answers your question, at least at a high level, that efficiency is still very much at the core of what we do in power generation.
Okay, would you like to add anything to that from an OEM point of view?
No, I think he said it quite eloquently. That's always the goal. And, you know, as long as you can continue to optimize, whether that you couple that with the production of hydrogen, injecting that into the gas turbine, you want it to be as efficient as possible.
Alex?
Well, from a retrofit perspective, I would say we also strive to, in certain cases, increase power. You mentioned California. I would say every state around California is currently asking for more power, and that also includes efficiency upgrades. So what we can do today with older type engines, I'd say, engines that were put in the field, back in the mid 70s, going, to the late 90s, F-class type engines. A lot of these engines can benefit either from flow down technologies, from OEMs, but also are equipped with PSM type technology, where we really look after a full conversion of these engines to upgrade, not only on the emission side, but on the power side and efficiency side. So efficiency is still very, very important. If you go over to Europe right now with crazy energy prices, I can tell you efficiency is king, okay, to just save whatever you can in terms of, in this case, mostly natural gas.
Thank you. Maybe we'll go ahead, please.
Hello. Yeah, so I'm just compiling the questions from the online chat session. My name is Sumit Basu. I'm a professor here. There are a few questions related to the source of hydrogen. So people are asking, if you have to use electrolysis, then how about competing with the freshwater sources, right? And then related to that, if you're using seawater, then how do you deal with the brine? And again, if you're using fossil fuels to generate hydrogen, how is that thermodynamically and economically feasible in the long run? So I would welcome the panelists to comment on this.
Yeah, I guess I'll take that, being an electrolysis creator. So yeah, water is always a challenge, right? The scarcity of water, we keep hearing stories about the Colorado River diminishing, and so we have to be strategic. A lot of the developers are looking to go to land where there's a well there. When we talk about nuclear power plants, they already have a cooling tower and already the permitting there. So one of the first questions that we do ask our developers and whoever is interested in creating a plant is, where are your water rights? Because you will need them. It's not a substantial amount, at least for the PEM electrolyzer that we manufacture. It's 10 liters per kilogram of hydrogen that's been demineralized. So it's not a significant amount, but it's enough that you do need a sustaining source. We are not on desalinization, at least not for yet. We do have an initiative for 2026 that's a electrolysis wind, offshore wind project that we are currently exploring. That's another R&D project within Siemens Energy. But you're right. What do you do with the brine? That becomes quite difficult. Currently, even though we still support on the service side for our fossil plants, we no longer provide new technology to a fossil fuel coal plant, because we do want to move forward. We want to be a cleaner company. We want to promote the reduction of CO2 and really, do a solid service for Mother Nature.
And maybe I'll add just a little on the fossil fuel piece. If you think of some of the levers that can be utilized in a fossil fuel-based facility, taking a SMR as an example, steam methane reformer, where you have natural gas, you can do a few things, right? You can utilize biogas, renewable natural gas coming from landfill or from biodigester, for example, to lower the carbon intensity. You can then layer on carbon capture, whether it's for sequestration or utilization. And these are all levers that can be utilized to take the technology that exists today and the variety of options to lower your carbon intensity, where you could even end up with a negative carbon intensity. So I think being able to utilize those different levers, even in the medium term, are powerful ways for us to advance in terms of the hydrogen economy, clean hydrogen economy.
Well, I think since we are coming to the end of the panel, I'll probably just conclude the panel first. Again, thank all of you, thank the audience, both in person and on the net. One thing that I like to say that what I got from today is a message of great excitement and opportunities for the technologies that yet to be implemented and the innovation that yet to be made. And that is where, being from an academic institution, we are so excited that we have got leaders like you on the stage here and kind of giving us some words of wisdom. With that, let us thank the panelists, and then that will be the conclusion of the panel.